judges wat daar sit. Ja, nee, ons is op die regte plekke.
Testing. We're good to go. Should I just start? And give it 2 seconds. All right. Ladies and gentlemen, welcome to this year's 2026 National IP Showdown, where we celebrate and commemorate all the research work done by the universities of South Africa. And today with us, we have the top students from the different universities in South Africa who are here to present and basically go for a showdown, a competition, where they showcase the kind of work that they did at their institutions, guys. So for that, can we give them a round of applause? Yeah, so the National IP Showdown is an event that's been happening for many years, and it's always good to just sit in this kind of environment where we're here with like-minded people and we're able to see the kind of work that everybody is doing. So at this event's been put together by Saice National, and it's a Saice National event. So with us from the national office, we have Sekari Payane Sekana, who is the CEO of Saice. So could everybody please give her a round of applause? We have our Saice president, Professor Chris Roth, who will actually come up to give us some words, but right now, could we just give him a round of applause for being here? Thank you very much, Prof. We have the head of marketing, Tabeleng, who is actually outside, but you've seen her move around, so I think you'll know her when you see her. So she's also here with us. And then she's followed by her marketing teams, Bongile, Naledi, Siabuka, and Lake, who are also somewhere. They'll be within this room, but they're around. So could we just give them a round of applause for all the work they put in? Yeah, so for this event is catering towards the young members and myself. My name is Victor Chibaya. I'm currently the FLP chairperson, the National FLP chairperson, and Saice FLP is the area of Saice which caters for members under the age of 36. And within FLP, what we do is that we prepare young members, being students, high school learners, and young professionals for the industry, and just do what we can to create a community for civil engineers and just to get them ready for things like professional registration, their first jobs, and all of those opportunities. So I just wanted to put it out there that that's what we do. And within the Saice FLP, we have student chapters. So I'm sure a lot of the students here would have been part of the student chapters. And yeah, it would be good to, I'd just like to say thank you to all the student chapters for all the work that you guys have been doing in the universities. It keeps everything going. And with UP, we also have a student chapter that might need some revitalization. So we'll be talking with our team from the University of Pretoria to talk about that. But yeah. We also have our judges today, and the judges that will be judging this prestigious event include Victor De Abru, who is the regional manager at SMIC, and he's part of the Saice Transport Division. Victor, could you please just show your hand so everybody can see who you are? And then we also have Refilo Lesufi, who is the Saice president-elect and managing partner at Prana Consulting. Refilo? We have Puti Khaditsi, who is part of the Saice Water Division as the vice chair, and she's a project manager at Rand Water. Puti, could you just say hi? We have Shirin Kasipersad, who is the CEO of SKI Engineers. Thank you very much, Shirin. And then last but not least, we have Lemo Monyati, who is the Pretoria branch chair, senior manager at Road Safety Engineering at the Road Traffic Management Corporation, RTMC. Thank you very much, Lemo. Yeah, guys, so again, thank you to our judges for being here to help us judge this prestigious event. And yeah, we hope that we have a good time and a lot of fun. So without further ado, I'll be calling up, before I do that, let me please give you guys some house rules. Let me introduce some house rules. So Phones, could the phones please be put on silence? We don't want the phones to be disturbing the event and to be disturbing the participants as they start. And then could you also, if you want to take pictures, could you also turn off your flash, except for the photography team, they can flash all they want. We're used to that flash. We're used to that flash, but everyone else, could you please not use flash when you take pictures, but you can take videos and pictures if you want to. And then also just, could we keep it down, not have too many background conversations while other people are presenting. Or if you go out this room and you take a immediate right and you just go follow that corridor, there'll be the men's toilet, which will be the first one you see on your left, and then if you just skip a door, you'll see the ladies' toilet on your left as well. And then if you decide to go through by just going straight to where we're eating and then go on your left, men's will be on your right, okay? And then, yeah, again, I'd just like to welcome everybody here. There's people from academia, there's sponsors, and there's parents. Welcome to the prestigious event. And now could I please have our Saice president, Prof. Roth, to come up and give us a few words.
Thank you, Victor. Afternoon, everyone. Thanks. Good afternoon, everyone. Yes, I've been asked to say a few words. First, I'd like to welcome some honored guests, our sponsors, BVI, McCaffrey, Spraylock, and the University of Pretoria, our judges who've been introduced, various academic staff, including our head of department, Professor Hannes Graber, who's here today, the Saice staff who's been introduced as well, the students, and of course, all of our participants who are sitting in various places. At first, I have to admit that I can't hide the fact that I actually work at the University of Pretoria. I didn't actually study here. I studied at one of the other universities that's taking part. But today, that doesn't matter anything. I'm neutral. I'm here as the president of the South African Institute of Civil Engineers. And I'm completely neutral, so may the best contestant win. Believe it or not, this whole Saice IP Showdown is actually not the first of this type of competition in South Africa. Back when I graduated, which was many, many years ago, there was a similar competition run by EXA, I believe. It wasn't restricted to just civil engineers, but all the engineering departments in the university. Each university had an internal competition with the departments and then nominated one person to go forward to a national event such as this. For various reasons, that died down over the years. I think it might be difficult for judges to evaluate the technical merit of a chemical engineer versus a civil engineer versus an electrical engineer and so on. But I'm very glad that Saice took it upon themselves to resuscitate this. In fact, it was resuscitated, I believe, in about 2014, and that makes this one the 12th edition, missing one during COVID. So really glad that it's continuing. In my inaugural address last year, I mentioned three themes that I wish to concentrate on during the year, being ethics, education, and heritage. This afternoon, we're concentrating on the second one of those, education. To be precise, education, the way I was interested in it, is not the continuing education, which is important, but more university education and also high school education, preparing students for careers in technical and engineering fields. Today, we're really concentrating on university education. And we see the results of that in the form of some projects done by the senior students. These projects should show that the students have attained the EXA graduate attributes that are tested in such a research project, such as the application of engineering fundamentals, data analysis, and professional communication. All three of these are absolutely essential in one's career as an engineer. I think I mentioned my inaugural address as well. If an engineer does not have a grasp of the fundamentals of engineering, he or she will battle throughout their entire career. Analysis of data and the drawing of logical conclusions remains very important as well. And whether we like it or not, professional communication is absolutely essential in a career as well. We have a stereotype of an engineer who doesn't like to write reports or stand and present anything, but unfortunately these are skills that have to be practiced and learned and will help all engineers throughout their careers. I, for one, am very much looking forward to see what our students have produced today. I'd like to congratulate all of our contestants who are here tonight and encourage you and congratulate you for pursuing excellence in engineering. There's no need to be nervous. The audience is all here and they're all ready to listen to you. A couple of remarks directed mostly at recent graduate students, who I've seen quite a number of you here today. Hopefully many of you were members of some of the Saice student chapters over the past few years. Whether you have or not, as your career develops, I would encourage you to join up Saice and to get involved with activities, whether it be at branch, division, panel, committee level. Many people ask, what does Saice do for me? Why should I join? I don't have a lot of time, so I can't go into a lot of detail now, but I do want to tell you that Saice offers you many benefits if you're a passive member, but even more if you are an active member. There are so many networking and leadership opportunities available to you by getting involved. The more time you put into it, the more rewards you will feel. The mission of Saice includes a couple of the following elements: to be a learned society for civil engineering, to enable our members to provide the communities with sustainable infrastructure, to create an effective communication channel with various stakeholders, to provide our members with continuing education, and to advance and uphold professional ethics, and to enhance the recognition of civil engineering as a highly respected profession, and to encourage our members to strive for excellence in engineering. As I mentioned earlier, all of our contestants today are striving for excellence in engineering, and we're really looking forward to hear what they have to say. Saice is active in all of these mission areas. You'll feel the benefits if you're a passive member, but even more if you're an active member. It's been well known for many years, in fact, I'm talking probably at least 100 years, that the public does not always recognize engineers as being a learned profession like they think about doctors and lawyers. There's a lot to be said about that, and I'm not going to go into it today. And one of the points of Saice's mission statement is, in fact, to improve and enhance the recognition of civil engineering as a highly respected profession. I believe that if you want to be a proud civil engineer and take your profession seriously, belonging to a learned society such as Saice is an important part of that. If you're a student and have finished your studies and have started working, please remember to update your status from student to graduate. It doesn't cost much in your first year. There's a sliding scale over 5 years. It slowly increases as hopefully your salary increases and your position and responsibilities in the company increase as well. Right, for those of you still not students and not yet Saice student members, please join. It's free as a student. Right, with that, I'd like to say well done to all of our contestants for making it this far. The theme I'm following for the year is Engineers Get Things Done. I'm sure that this afternoon from our contestants we will see many examples of how engineers get things done. Good luck to all of our contestants. Let the contest begin. Over to our MC.
Prof. Yeah, guys, so you guys heard that the theme of our president for this year is Engineers Get Things Done. So let's get right into it, where we're going to see the different things that have been happening at the different institutions to get things done. So to begin, I'll go for our first presenter from the University of Cape Town, Akila Sharif. So Akila Sharif's project's name is, or in fact, while we're putting it up on the screen, I'll talk a little bit about Akila. So Akila Sharif has a favorite book called it's called 1984 by George Orwell. 1984 by George Orwell. Maybe she'll give us a mention of what it's about when she gets here. And her favorite quote is, "Pressure is a privilege. It comes only to those who earn it." So being here, I'm sure there was a lot of pressure that got you here, and you'll be a little bit under a little bit of pressure here. But clearly you love the pressure, and yeah. You earned it, and you're about to do it. So Akila Sharif, please come up and present about P for Profit, exploring inside nutrient recovery. Ooh, it's giving us problems. Oh. Okay, so can we just get 2 seconds because we're having some technical difficulties? But yeah, 2 seconds while we have some technical difficulties. Maybe Akila could mention what her book is about while we wait. Oh, she said no. She said no. I'll tell you about my favorite book then. So, yeah. Okay, so I'll tell you guys a bit about my favorite book. And yeah, my favorite book is Reinforced Concrete Design to Eurocode 2. So when I saw these, I was like, hey man, I need to get a bit more out there and think about things that are a little bit more diverse, because I'm very much focused on work. But yeah, no. Let's just sort this one out, yeah. USB. It's taking time. Should even open them all. We should open them all. Are they on a USB? It's still loading on both. There, it's up on the top, but it's not here. All right, now it's still. There we go. All right, guys, so we have Akila Sharif from the University of Cape Town. P for profit. Take the floor, Akila.
Thank you. Okay. Good afternoon, everyone. My name's Akila, and I'm from the University of Cape Town, Department of Civil Engineering. Today I'll be presenting the findings of my final year research project, which explored the potential for on-site nutrient recovery and water reuse. I'll start my presentation off with identifying the problem, followed by outlining the solution. I'll then discuss the location for the proposed intervention, followed by the methodology and results of my research. I'll conclude my presentation with a short summary of my findings. It's not going. Let me just. It's not working. Sorry. Right, so let's look at the problem. Urbanization and rapid population growth are placing unprecedented stresses on limited freshwater resources, with 51 countries expected to suffer from high water stress by 2050. South Africa is no stranger to this water crisis, with major cities like Cape Town and Johannesburg having experienced this crisis firsthand. In addition to water scarcity, population growth is also increasing the demand for synthetic fertilizers as they provide growing nations with food security. Global fertilizer consumption was roughly 190 million tons in 2023, and the three main nutrients found in these fertilizers are nitrogen, phosphorus, and potassium. But producing these nutrients is energy intensive. Ammonia synthesis alone accounts for about 1.2% of global anthropogenic carbon emissions, and phosphorus must be mined from phosphate rock, which is a limited, non-renewable resource, which raises sustainability questions about long-term fertilizer supply. It's therefore important that alternative fertilizer production methods are explored. Now, what if there was a single resource, one we all produced every single day, that could help solve both of these problems? Luckily for us, there is. The solution lies with human urine. Human urine is typically regarded as a waste stream, but from a nutrient perspective, it's actually a gold mine. It makes up less than 1% of wastewater by volume, but it carries up to 80% of its nutrient load. It also contains the three key nutrients typically found in fertilizers. Furthermore, urine is 97% water, so by recovering the nutrients and the water from urine, we can contribute to broader goals of sustainability and help cities like Cape Town and Johannesburg become more resilient to the growing water security challenges it continues to face. The question that follows this is, where do we do this? Globally, nutrient recovery from urine isn't new. University buildings, malls, offices, they've all piloted or investigated urine diversion and collection systems. But there is one setting that has not yet been explored, and that is stadiums. Stadiums don't behave like these previously mentioned settings because these settings benefit from a consistent flow of urine, whereas stadiums produce large volumes of urine during events and then nothing in between them. And because of this distinctly different usage pattern, they needed their own modeling and their own analysis. The next critical question is, how do we do this? The concentration method chosen for this study was reverse osmosis due to its ability to be applied at scale. Reverse osmosis is the dominant method for seawater desalination worldwide, demonstrating both its reliability and scalability. Reverse osmosis desalinates urine in the same way that it desalinates seawater. It provides us with two product streams, a concentrated nutrient-rich stream, which is the brine or the liquid fertilizer, and then a permeate, which is essentially just water. Reverse osmosis has the ability to remove all of the flash water that the urine is diluted with, as well as the ability to further concentrate the undiluted urine. For this study, a 60% water removal from the undiluted urine was targeted. Now, with all that in mind, the core question of my study was refined to this. What is the potential for the Cape Town Stadium to recover nutrients and reuse water on site from urine collected during events? And to obtain a clear-cut answer, 4 objectives were outlined. First was to quantify how much urine the Cape Town Stadium could realistically collect within a year. Second was to estimate both the capital and ongoing operational costs of a practical treatment system. Third was to examine how the dilution of urine with flash water affects feasibility. And fourth was to assess the water-saving potential of reusing the water recovered through reverse osmosis to flush the stadium's urinals. Sorry, it's just frozen again. It's frozen. Okay. To achieve those objectives, the method followed was simple. The study began with designing a treatment train that could be implemented at stadium scale. Next was to gather the data and characterize the site with attendance patterns and fixture counts. With that information in hand, the next step is economic modeling, estimating the capital expenditure, the operational expenditure, and the revenue potential of the recovered fertilizer. And last, but certainly not least, was the water-saving analysis to quantify how much potable water supply could be offset by reusing the water recovered from reverse osmosis to flush the urinals. Now let's look at the treatment train designed for the stadium. The fresh urine collected from male urinals only is stabilized with hydrogen peroxide to prevent nitrogen loss. The collected urine is then stored in large collection tanks, and the urine is fed from these collection tanks into the reverse osmosis plant, which can concentrate about 3,200 liters of undiluted urine per day, and it concentrates the urine collected from one event over multiple days. The fertilizer produced is then collected in flow bins, and these flow bins are transported to a warehouse facility where the product is packaged and distributed from. This treatment train is fundamentally different from previously done research because it eliminates the need for major retrofitting of existing plumbing fixtures, which significantly reduces the initial capital investment. It uses the urinals in the stadium as is. Now, let's talk numbers. What I found using the available data for the Cape Town Stadium was that male urinals could yield about 135,000 liters of undiluted urine annually, and by concentrating the stream, we could potentially produce 54,000 liters of liquid fertilizer and recover 81,000 liters of water. Now let's look at the costs associated with the system. It was found that the modeled system requires an initial capital investment of about 1.47 million rand and has an annual operational cost of 2.9 million rand. And at these costs, the break-even price or the minimum sale price of the liquid fertilizer is approximately 60 rand a litre when calculated over a 5-year investment period. When we take a look at the fertilizer market, however, it's evident that the fertilizer could be sold at more than double this break-even price when sold to specialist buyers like nurseries or home gardeners. And how did we find that out? So, the weight percent of nitrogen in the fertilizer determines the potential selling price of the fertilizer. The higher the nitrogen content, the higher the price the fertilizer can be sold at. For a 60% water removal from urine, the weight percentage of nitrogen was calculated at 1.5%. And at this weight percentage, we could potentially sell the fertilizer at 137 rand per litre. And if all the recovered fertilizer is sold at this premium price, the annual revenue can reach as high as 7.4 million rand per year. And this 7.4 million rand annual revenue translates to 4.5 million rand pure profit. Next, I also analyzed what effect changes in certain parameters would have on the break-even price of the liquid fertilizer, as this would directly affect feasibility. And it was found that the most influential parameters were the operational cost and the volume of fertilizer produced. If you look at the graph on my right, we've got percentage increase in cost on the x-axis and the fertilizer break-even price on the y-axis. The blue line represents the capex and the yellow line represents the opex. So now we can see that for a 50% increase in capital cost, the break-even price of the fertilizer increases from 60 to 65 rand. However, for a 50% increase in operational costs, the break-even price jumps to 85 rand, which highlights the model sensitivity to the operational cost of the system. Then, the next graph, we've got on the x-axis the volume of fertilizer produced and the break-even price on the y-axis. And we observe an exponential relationship between these two parameters. And this is because as the volume of fertilizer produced increases, the cost per unit decreases, which results in a lower break-even price. And then conversely, if you produce less fertilizer, your cost per unit increases and your break-even price increases. Now, let's dive into dilution. So understanding dilution is essential. Dilution is defined as the ratio of flash water volume to pure undiluted urine volume. For example, 100% dilution means that for every 1 liter of urine, there would be 1 liter of flash water, which translates to 2 liters of diluted urine stream. It's important to note that the higher dilution does not change the volume of fertilizer produced annually. Fertilizer production is based on the undiluted urine collection. What dilution does affect is the processing time. The higher the dilution, the longer it takes to produce the fertilizer. The study assumes an annual available operating window of 192 days, so the plant must comfortably process the diluted urine volume within that window. And at the dilution of roughly 357%, the current plant with a capacity of 3,200 liters per day reaches the limit of the available 192 operating days, so any dilution beyond this point means we need to increase the plant's capacity. And finally, the water saving results. Frozen again. Okay, I want everyone to picture this. The Cape Town Stadium on a sold-out night. Over 50,000 people watching the Stormers versus the Bulls. The Stormers lead by 5. The lights are flashing and the crowd is cheering. However, behind this spectacle, hundreds, if not thousands of liters of clean drinking water gets flushed away between halves at the end of the match as everyone leaves the facility without giving it a second thought. This routine behavior is exactly where the challenge lies and where on-site water reuse can make a practical difference. In the 2023-2024 financial year alone, the stadium used 33 million liters of water, of which 4.4 million liters can be attributed to the flushing of male urinals. Now, usually, water reuse systems need to supplement water losses in the system either due to leakages or evaporation with some form of municipal water supply. This reuse system, however, is truly circular. The extra water removed from the undiluted urine covers any potential losses that may occur in the system, removing the need for municipal water supply entirely. For the model system, the water reuse for the flushing of male urinals could save the stadium up to 277,000 rand per year, meaning that through water savings alone, you could cover the initial capital investment cost of the plant within 5 years. Now, based on these results, the next logical step is implementation at the Cape Town Stadium. The first installation has already been confirmed for this year, supported through partnership with Bidvest, who are working directly with UCT as the stadium's facilities manager. A JoJo tank has already been installed on site, marking the first physical step towards bringing the system into operation. This research also supports several sustainable development goals as defined by the United Nations, in particular SDGs 2, 6, 11, 12, and 14. And how does it do this? For SDG 2, it helps strengthen food security through the local production of fertilizers. For SDG 6, the system improves water management by reducing pressure on wastewater plants and making water reuse more efficient. For SDG 11, it applies circular economy thinking, helping us turn waste into a useful resource. For SDG 12, it promotes a more responsible way of producing fertilizers. And finally, for SDG 14, diverting the urine from the sewers reduces the nutrients runoff into oceans and rivers and protects the ecosystems in these water bodies. This research also fulfills the 3 ESG principles, and fulfilling these principles was essential for our partnership with Bidvest. Environmentally, it reduces the nutrient pollution in water bodies and lowers stresses on potable water supply. Socially, it turns urban settings like the Cape Town Stadium into visible examples of sustainability and supports nearby farmers by producing fertilizers locally. From a governance perspective, the system is designed around safety, transparency, and clear monitoring, encouraging strong partnerships between local government, sponsors, and researchers. In summary, the analysis shows that the Cape Town Stadium could potentially collect 135,000 litres of urine a year, which can be concentrated into roughly 54,000 litres of liquid fertilizer. And if all this fertilizer is sold at competitive market prices, we could achieve an annual revenue of up to 7.4 million rand a year. There's also the added benefit of an estimated 277,000 rand a year saved if the water recovered from reverse osmosis replaces the potable urinal flushing water supply, which could cover the capital investment of the plant in 5 years. This project has the potential to turn the stadium into a visible example of sustainable urban practices, helping cities like Cape Town take a meaningful step towards net zero waste. But the bigger picture is that stadiums are only the starting point. The same model for on-site nutrient recovery and water reuse can be applied in various other contexts, particularly in new large commercial and office developments, hospitals, other event-based venues, and can even be implemented at festivals with portable urinals, where plumbing and services can be designed or arranged to accommodate this kind of treatment system. When implemented in the right context, the model system can scale far beyond a single venue. The opportunities are endless. I leave you with this. You never change things by fighting the existing reality. To change something, build a new model. Thank you.
Thank you very much, Akila. So yeah, the only comment I have is that I just couldn't picture that the Stormers were leading by 5. But yeah, guys, could you please do 5 minutes of questions? If the judges have any questions first, could you guys do some questions? And then if the judges don't have questions, we might open up the floor to the audience.
Congratulations on that brilliant presentation. I think it was very thorough. Clearly got the technical acumen. Let me assist you. Linked to the entrepreneurship side, with the product that you will be producing, how do you think you will be packaging it? And the market is ready. Because your calculations are very dependent on that as an off-taker. Thanks.
So there have been many surveys done on this. And as the time progresses, the surveys show that as we move towards more sustainable development, people are more accepting of these fertilizers. So there definitely is a market for it. It is very important, though, to start off with buyers like nurseries or like people, niche market, rather than bulk agricultural buyers, because it's a little bit more difficult to get into that market. You can market to like nurseries for being sustainable, and we've also we're doing pathogen testing and stuff, so we can guarantee that it's safe, and you can market that easier to a niche buyer. But for bulk buyers, it is a bit difficult to get into that market because they first want to see that the fertilizer is reliable before they rely on that supply. So the target here is to target that market. The market that we can get into, which is this niche market with niche buyers. Yeah.
Hi, good afternoon. Great presentation and delivery. My question is, has the effect of antibiotics or the medical sensitivity been looked at? Do we have antibiotic residue in the fertilizer at the end of the product?
Yeah, so there definitely is. And currently there's a project running with ion exchange to remove these leftover pharmaceuticals and antibiotics in urine. Yeah.
Do you have any questions from the audience? So from my side, I actually also had a question, which was, how does this compare to currently available fertilizers? As in, you said the prices, but I don't know fertilizers too well to know, is it a competitive price or is it slightly more expensive or cheaper than the ones that are available in the market now?
So the break-even price for the system is 60 Rand, right? And then what we did was we investigated the fertilizers on the market and made a graph, like statistical relation graph, with nitrogen percentage and versus price, right? So the 137 Rand comes from that market. So at this weight percentage, 1.5%, that's what the market sells fertilizers for, but our break-even price is only 60 Rand. So we can enter the market much lower, really competitively, and still make a profit. Yeah.
Okay. We have a question.
I wanted to ask a quick question. The application that you have, a collection at the stadium, is a very kind of niche application. What is the potential to apply this in a more widespread kind of way? Do you understand what I'm saying?
Yeah.
In terms of a societal benefits, obviously the volumes would be much greater.
Yeah.
What would the challenges be in that case?
Yeah. So I think first, you can't necessarily implement the system in places where the plumbing is kind of hidden, because then you'd have to break open, you'd have to change all the plumbing, and that's what increases the capital cost, which is why it's targeted more to stadiums. So if you've ever seen in parking lots, the irrigation or like the fire sprinklers, the stadium's plumbing is exactly like that. It's all external, so it's really easy and really cheap to just connect it. So if you're building a new office development or something like that, you can design the plumbing to be like that and then implement the system. Because again, the system's capacity can always be increased. You can have you can add membranes and add membranes and add membranes, but it's more the actual implementation, putting it in, that is the barrier. Yeah.
Thank you. Good answer.
Thank you.
We're going to take our last question over here.
Great presentation, Akita. I just wanted to find out, maybe you might have mentioned this, I might have missed this. In terms of the fertilizer product that comes out on the other end, do you have some form of stability in terms of, you have a source that varies, I assume. Someone mentioned antibiotics. So when you come out on the other end, are you able to consistently produce your nitrates and so on and so forth where you want them, or how do you manage that process?
Yes. So that's why we're running a test at the moment, or plan to run the test now, to see what kind of variations there are and what we can do about it. But likely, you'll probably just design for the worst case and dose chemicals needed to that amount, because then you'll be fine every other time. Yeah.
Thank you very much. Okay, last question, and then we move on to our next presenter. You're fine, but speak loud.
I know that your case study was around stadiums specifically. I work a lot with wastewater treatment plants, so
Okay.
I'm curious to what extent can we then retrofit our plants to have your system, and have you thought along those lines, and what other ideas can come out of that?
Yes. So the challenge with wastewater plants is that the feed is urine and fecal matter mixed. And fecal matter presents a really big challenge because it's a lot more volatile, it's a lot more, it's got a lot more pathogens, so it's a lot more difficult to treat, and it's going to really increase the price. Like, you're going to have a pretty extensive system. And then also the other issue with fecal matter, it's going to cause damage to the membranes, the reverse osmosis membranes, and then you're going to have to keep changing that membranes, and that's also going to increase the cost. So it's very specifically for urinals or urine diverting toilets.
But I'm thinking maybe an extraction point at the BNR would, maybe at the end of the BNR would suffice, because at that point, the fecal matter is relatively at a very small point.
Yeah, but it's the moment that it comes into contact with the urine that it desterilizes the urine, because urine technically is sterile. It's considered sterile. It's not, doesn't have any existing microorganisms, stuff like that in it, where fecal matter might. So the moment it's in contact with fecal matter, we've got a problem. Yeah.
Thank you very much, Akila. That was actually a very insightful presentation. And if that's not engineers making things happen, I don't know what is. So thank you very much, Akila. Next up, we're going to have our speaker from the University of Johannesburg, Musa Jabulani Pulwana. Yeah, so a little bit about Musa Jabulani is that his favorite book, so very similar to mine, is Wastewater Engineering, Treatment and Resource Recovery by Metcalf and Eddy. So yeah, the textbooks have been keeping us entertained. And his favorite quote is that learning is the habit that turns challenges into progress. So yeah, give a round of applause for Musa, who is going to be presenting about exploring the quality of groundwater from the basement of the QK building at the Doornfontein campus. So yeah, all the best, Musa. Let's see what you'll be presenting. While we wait for your presentation to load, do you want to maybe give us some insight about your favorite book? What is the biggest thing you took from this? You're still thinking you need to focus on this one, eh?
Yeah. If I lose focus,
You'll lose everything.
But the book is all about integrated water resource management. Yes, it's all about using integrated water resource management. How can we conserve water? All those things.
Okay.
It's a lot. You must try that book out.
Okay, something is going on. I think we're going to have to change machines.
Oh, can I take my laptop? It's fine.
You can bring it.
Send them out to me.
Yeah, I think we need to change machines. No, he's just bringing his machine there. So now it's opening. Do you want to use it?
I saw it freezing, so I don't want those mistakes.
Connect to the email.
You okay?
That's one.
Take it away.
Good afternoon, everyone. As I welcome you again to the 2026 Saice National IP Showdown. My name is Pulwana Musa Jabulani, and I'm here to represent one of the best universities in the world, and currently the best because it is ranked #1 when it comes to engineering, to physical sciences, to computer science, to business and economics. So without wasting any time, I'll give you a short presentation on exploring the quality of groundwater from the basement of the QK building at Doornfontein campus. Doornfontein campus is one of our campuses, or one of UJ campuses. So my presentation today will cover some abstract, introduction and problem statement, research aim and objectives, literature review, methodology that I've used. Also, I'll present to you my key results, where I will talk about the physical, the microbiological, and chemical parameters. And then it will conclude by my own recommendations and conclusions. So without wasting any time, let's begin with some abstract. So this study investigated the quality of groundwater that collects at the basement of the QK or Toboza cluster building at UJ Doornfontein campus. So I collected hard data where samples were analyzed, and then they were analyzed for different parameters such as physical, microbiological, and chemical parameters, and compared to SANS 241 of 2015 for drinking water standards. So this, the results showed that this water is not good enough for student consumption or for human consumption. So you will find out more on the presentation based on results. So let's move to introduction. As we all know, that South Africa is a water scarce country. So every source of water must be considered. In this case, the source of water being groundwater. And we all know that globally, we have 97% of salt water and 3% of fresh water. And then groundwater accumulates 30% of that 3% of the fresh water. So this source is a very crucial source, so we must take it into consideration. So as I have said, my study area is the University of Johannesburg, as shown in the picture. That's the building at QK. That building is known as the QK or Gqoboza Cluster building. So this water collects at its basement, but its quality remains unknown. Students are using this water, but we are not sure if this water is safe for human consumption or not. So contamination of this of groundwater can be sewage leaks, can be urban rain pressures or runoff, can be old mines. As we all know that Johannesburg was covered by old mines. So this brings us to the core question, that is this groundwater safe for human consumption or not? Because students are using it and we don't know if it's safe or not. So I'll quickly move on to the problem statement. So my problem statement goes hand in hand with my introduction. Yes, we do have the water that collects at the basement, but is it safe or not? So this research project has some aims and objectives. So my aim was to comprehensively assess the quality of this groundwater that collects at the basement and compare it to SANS 241 of 2015. So my key objectives, the first one was to analyze the physical, the chemical, and microbiological characteristics or parameters. So my second objective was to also identify the key or the major sources of this contamination. What is it that is contaminating this groundwater that us as students we want to use? Then the last one being to provide actionable recommendations for management. How can we manage this water? So I'll move on to the literature review. So this one is based on what other authors have found. So other authors have found that groundwater supplies approximately 21 to 30% of global fresh water. And this groundwater is a very crucial source of water in dry countries such as South Africa. So I also found out that Johannesburg faces specific risks, such as sewage leaks, such as acid main drainage, and urban pressures. So I'll quickly move on to the methodology that I've used. So my methodology is divided into two parts. First part being the research, design, and sampling. Then second part being the laboratory analysis. So the research design that I evaluated, I found out that it's a quantitative and cross-sectional research design where it involves the collection of hard data. So this is where I had to go to the building and collect data on 4 different sand pits. So on the picture, you can see it's a picture of one of the sand pits. I couldn't use 4 all pictures. I decided to use one because they are all the same. Then I systematically gathered data for 15 days period during both dry and wet season. So all these results or all these results that I'm getting, I have to compare it against the SANS 241 of 2015 for drinking water standards. Then I'll quickly move on to my methodology part 2, which is laboratory analysis. So this is where I tested my physical, my microbiological, and chemical parameters. So as indicated that my physical, it tells us about the basic water condition. Then my microbiological test for dangerous bacteria, where my chemical test for harmful substances and indicates what type of pollution is it. So the goal was to create a complete quality profile and also to identify specific contaminants that are leading or that are exceeding, safe limits. Then quickly moving on to my results. I'll start with the physical parameters. As I've said, that this one tells us about the basic water conditions. So here I had to test for my pH, my electrical conductivity, and turbidity. So if you check for electrical conductivity, all my samples were okay because they were not exceeding 170 according to SANS 241. If you check my turbidity, some samples were okay, some were not, meaning that this water might have been contaminated by acid mine drainage. Then if you check my pH, almost 90% of my pH values were fine, except one day, which was day 5. And what was the cause of this 4.13. And this 4.13, it shows that this water, it is highly acidic. What was the cause? When I went there to take my samples, as I've said, it involves the collection of hard data. When I went there, there was heavy rain. I wanted to check how does groundwater, how does this water react? How does also the water table react to this groundwater when there is heavy rainfall? So that is why my pH has decreased to 4.13. But the others are all right and are all falling the range of 5 to 9.7 according to SANS 241. So I'll quickly move on to my graphs. So this is the pH graph as shown, but if you can check on day 5, it couldn't reach the limit of 5 because according to SANS, it says it must range between 5 and 9.7. Then this shows that this water is contaminated by acid mine drainage or old mines. Then we have the turbidity graph. So as I've said that 50% were good, 50% were not good, also indicating that this water has a big problem. Then I'll quickly move on to my microbiological parameters. So these ones, it tells us about the pathogenic organisms. So this is where I tested my total coliforms and my E. coli. So if you check, all my total coliforms values were not okay. They were more than exceeding the limit of 10. So this alone indicates that water is being contaminated or it is being affected by a broken sewages that we have at Johannesburg. Then also my E. coli, it was supposed to give me 0 somewhere less than 0. Some samples were high, and also we have a very high value there. Then moving on to the graphs, it shows that my total coliforms, all the samples are exceeding the SANS 241 standards. And also for my E. coli, some are less, some are high, which shows that this water is contaminated by sewage leaks. Then moving on to my chemical parameters. So my chemical parameters is divided into 2 parts. So here, this is where I had to test my nitrate, my sulfate, my sodium, iron, and chloride. So all my 4 testings were fine, but I had one critical failure because, I tested my nitrate. My nitrate were found to be okay. Then my sulfate were not okay. Then my sodium were okay. All the values were less than 200. Also my iron, all the values were less than 300. Chloride, less than 300 according to SANS 241. But I had one critical failure, which is sulfate. And all samples were ranging from 675 milligrams per liter to 720 milligrams per liter. Moving on to part 2, where I will discuss this critical failure. So what was the problem? The problem is that all these levels were approximately 35 to 44% above the SANS 241. Not even one sample was ranging on the range according to SANS. What is it that this means? Why am I getting this? This indicates that this water, it has a chronic source of contamination, which is mostly likely to be sewage and acid mine drainage from the historic Witwatersrand Basin gold mines. So other possibilities can be urban runoff or urban pressures and other things. And this one can cause bad taste. So moving on to my recommendations and conclusions. So my conclusion, I found out that this groundwater is unsafe for human use or for students without extensive treatment, meaning we have to treat it by using chlorination, we have to add lime, and then I found out that the major source or maybe major source of contamination is the leaking sewer. Then my key recommendation is to restrict access and post warning signs. As it is a university, it's a student's building, we have to post signs at the bathroom saying that do not drink this water. This water is not safe for human consumption. Then we also have to investigate us as the university. We have to investigate and repair the sewer lines because there are a lot of damaged sewer lines. Then we also have to establish a continuous monitoring program and integrate groundwater into the university sustainable policy, meaning we have to set up maybe at least 30 to 1 hour program where we educate students about this groundwater. So without wasting any time, I would like to show you these are the references that I've used, and then I would like to thank you and thank you to our sponsors.
No, thank you very much for that wonderful presentation. Yeah, guys, so could we please open the floor up to questions from judges first, and then if we still have time, we'll go to everybody else. But yeah, that was a very good presentation, and yeah, the floor is open.
Hi, thank you for the presentation. So you mentioned in the presentation that twice that the students are using this water already. We then saw in the presentation that your research concluded that the water is unsafe. You mentioned that your recommendations was to restrict access and have warning signs as well as try to educate the students on this. Has any of those three items been actually done? Has the signage been put up and access restricted?
So since this research was done last year, and I was the first one to do it, to find out if this water is safe or not. Then signs were not there, but now the university is planning to put signs on the bathrooms because this water is being used on the bathrooms. We don't have taps where they can just go with a bottle and pick up and drink. So the signs are being put right now.
Mine is a clarity-seeking question. So you mentioned that it's groundwater, right? And it collects in sumps
Yes.
in 4 separate locations. So how do the learners actually access that water?
Oh, that water is being pumped. They install the pump. It's being pumped and then it's given to the students.
Oh, so they pump it into like a JoJo tank and then they feed it through the pipes?
Yes, but they are not supposed to drink. There are no taps. It's just used in the bathrooms for flushing and for washing hands only.
Okay, now it makes sense. All right, thanks.
My question is, how deep is it the point at which that water is being collected? And if you had to collect that water deeper down, would it make a difference in the quality of the water?
Sorry, I didn't catch.
What I'm saying is the depth at which that water is being collected may be a reason for the contamination. If you had to collect that water deeper down, would it make a difference to the quality?
I don't think it will make a difference because this water currently is affected by the sewer, the leaking sewer and the old drainage or old mine drainage. So I don't think there will be any difference. The results were going to be the same.
So what is the depth of that point at which it's collected?
What is the depth?
The depth below ground level, natural ground level.
Where the water collects, or the depth was found to be, I think it was 800, it was ranging between 800 to 800 meters. Yes, no, 800 millimeters, I'm making a mistake. Yes, mils, yes. 800 mils, yeah, it's just a minor mistake.
All right, now thank you very much. Those are the questions from the judges. We can take 1 or 2 from the rest of the audience. Does anyone have questions? All right, in that case, there we have a question over there. Let me go give him a mic.
Hi everyone. I wanted to ask on the signs that we're going to put up. Like, if some other students decide to be ignorant, what are the safety measures that we're going to implement in terms of aiding them?
What?
But it's not for you.
Okay. I wanted to ask on the signs that we're going to put up because of the contamination of the water, the
Yes.
groundwater that you were investigating in your research. So I wanted to know if are there any safety measures implemented for any students that are going to maybe consume that water by mistake? Because you said like washing hands. I don't know. Because that means like there's a tap somewhere in the bathrooms or the toilets that they're going to wash hands. Maybe someone else may decide to drink them. Is there any safety measure that the university is going to implement to maybe aiding those students or what?
Well, as educated as they are, I believe, I believe that if they see the signs, the warning signs, I don't think they will drink that water, because even right now, without the signs, they are not drinking that water. We haven't had any of single students saying they are sick because of that water. So that water, they are not drinking it, but we are going to put signs. Remember, every year we accept a lot of students. So when they come there, they can say, oh, this water is not supposed to be drank.
So, final question over there.
I'm piggybacking on this question. What measures then does the university then take to put in place, because it's a legal problem if someone actually ends up getting sick, to protect themselves as an institution? Or to, yes, we've put up signs, but people do whatever they want at the end of the day, and they might still drink the water. So maybe as part of your recommendations, I'm saying maybe there should be something that says, to the legal extent, what the institution should then do. Yeah.
Oh, thank you. So remember, for warning signs, it's just for temporary. I talked about that we have to treat that water. We have to add lime. We have to do chlorination to it. So for warnings or for signs, it's just a temporary time. So we are going to remove the signs because that water will have to be treated.
Satisfied. There was one last question that came in, but I hope it's a very quick one with a very quick answer. So we'll give you that last question, and then that's it, yeah.
Thank you. My question is on that building traffic.
Can you pause so I can give you a mic? Oof.
I try to fill out.
No, it needs to go for the online.
Oh.
Can we not pass it through? Yeah, but yeah, guys, we are running behind on time, so for the next ones, I'll be a bit more strict. So yeah, think of your questions in advance, and then.
Right, thank you. I think my question is on the traffic around that building in terms of people. Currently, what that building is used, and then in terms of the building using borehole water, is there currently signs that says the building is using this type of water or something like that? I'm not sure if they asked that. And then, yeah, I think that's it.
No, currently there are no signs, but that water is still getting out of the building. So as you know, that Johannesburg is full of taxi drivers. So they are using that water to wash their cars. So that's what is currently happening. But the day I went there to investigate, I told them, guys, if you've been drinking this water, stop. Do not hesitate. Stop drinking this water. Go and buy water. So that's what I had to tell them.
Okay. No. Thank you very much, guys. Again, I like the presentations we're getting. Let's go. All right, guys. So the next presenter we'll be having is from the University of KwaZulu-Natal, Mhleli Lutuli. Mhleli Lutuli is going to be coming from UKZN, and his favorite book is The Power of Positive Thinking by Norman Vincent Peale. Mhleli, please come up. Please put this on just so that we can get some audio. I want to mess up the fit. There we go. Yeah, so a quote from Mhleli's Endurance is not just the ability to bear a hard thing, but to turn it into glory, by William Barclay. So Mhleli, please take it away. And Joe, we're looking forward to hearing what you have to say.
Okay. Okay, thank you very much for the opportunity I've been receiving. As I've been introduced, my name is Mhleli Lutuli, coming from the University of KwaZulu-Natal. So today I'll be presenting my research where it studies the durability performance of limestone calcinite clay cement and platinum slag waste for concrete paving blocks. And this was an experimental study. So this research work seeks to address South Africa's ongoing issue with industrial waste and transforming it into an infrastructure asset and sustainability. And this research also demonstrates how we can simultaneously tackle the issues of global carbon emissions while also addressing the need for sustainable infrastructure within our country. So briefly, just to touch on the motivation behind the research itself, if we look at the global context, we see that the construction sector alone is responsible for up to 37% of global carbon emissions. And specifically looking at the Portland cement production sector, up to 10% of carbon dioxide emissions comes from this. So these figures were enough to really strike that urgent need for sustainable alternatives. So where do we fit in as South Africa? Where do we take a step forward and do something about this? We look at the opportunities that presented to us as South Africa as the country. As the world's leading platinum producer, we look at the vast amount of platinum slag waste that is being produced after we process our platinum products in the platinum mining sector. And we also look at the abundant clay resources that are available within the country to produce our elements, our products such as limestone calcinite clay. So the solution came about to take these two materials, which was limestone calcinite clay, I'll be referring to as LC3, and also the platinum slag waste. So the limestone calcinite clay with the motive or the goal to reduce our carbon emissions when replacing it with that Portland cement, and then the platinum slag, which will be replacing our general aggregates or our fine aggregates within our concrete mixture. This would also promote our industrial waste valorization or recycling within the country. So now getting into the first of our study materials here, I was looking at LC3, limestone calcinite clay, which is an engineered blend containing 50% of your normal Portland cement, also including calcinite clay and limestone and then gypsum. So how it actually works is that we start off with that hydration process where the clinker content from the Portland cement is reacting with water, forming our Portlandite, supported with that cementing phase, the calcium silicate hydrates. And then the Portlandite that was produced would then go on to react with the metakaolin. That is as a result of introducing our calcinite clay. So that metakaolin reacting with Portlandite will create those secondary cementing phases, those additional bonds within our concrete mixture itself. And then ending off where the limestone is reacting with the alumina to form our carboluminate phases. Now, these are the compounds responsible for refining our pore structure within our concrete mixtures. So looking at the benefits of using this material, as I had mentioned, it sees to reduce our carbon emissions by up to 40%, while also giving comparable strength with our Portland cement. And we are also using locally available materials in this instance. The second of our material here, which we are looking at, is the platinum slag waste, which is the byproduct of the platinum smelting process, which is present in abundance currently in our country. And we look at its composition with its major and minor oxides, but most interestingly, the amorphous silicates and glass matrices, which see to give us the benefits of that spherical and glassy morphology, giving us that ball-bearing effect. Now, the ball-bearing effect in this instance is when we're getting a reduction in friction within our concrete particles and our aggregates, introducing that increased workability within our concrete mixture. And then also looking at the benefit of denser particle packing within our aggregates, and also the key benefit, which would be valorizing our industrial waste being produced in the country. So now, to set up the goals for the research itself, it was to conduct the comparative investigation on the durability performance and the microstructure of the conventional paving block versus the block that is incorporating our replacement materials at 15% and 45% levels. Now, the Portland cement, as I had mentioned, will be replaced with the LC3, and then the river sand will be replaced with the platinum slag waste. The objectives was to develop our design mix using the PRE method, and then evaluate our concrete in 14-day early age testing, and then also validate our results using our microstructure TGA analysis, and then determine whether replacing our normal materials in concrete mixture would be viable. Now, the experimental methodology that I developed before going into the lab was to develop our design mixes, which included 3 of them. The first one was the control mix, or the benchmark mix, where there was 0 replacement of my Portland cement and river sand. Then the second and the last mixture was replacing it with 15% and 45% respectively. So the testing protocol followed was to develop that mixed design using the PRE method, and then follow the casting procedure, and then the curing stage of 14 days, that early age curing stage, and then also to cast and core my samples for testing. So now, to get down to the durability itself, to conduct and really get the results, the indices that we used were firstly the oxygen permeability, which determines the resistance for cement-based materials to really repel or resist the ingress of oxygen within our concrete samples. Secondly, we look at water subtivity, which determines the hindrance occurring within that water path due to the capillary suction of the section of the surface specimen. And then lastly, the chloride conductivity, which determines the resistance for penetrating chloride ions within our concrete mixture. And then the microstructural analysis would then be done to validate our results. Those analyses include the TGA and the SEM analysis. So the procedure followed was as follows: to cast on cubic molds, and then follow a standard procedure of vibration, and then curing for in the water bath for an early age of 14 days. And then the specimens were extracted, and then cored and saw cut to specific dimensions according to standards, and then it would then follow the durability testing of our specimens. So this was just our procedures followed. On the far left-hand side is the procedure of coring our specimens, followed on the right-hand side by the saw cutting of our materials in the lab. Now, material characterization was key in order for us to be able to understand the result that we would obtain. And the key findings here within the SEM analysis is that with the limestone calcinite clay, the LC3, it was dominant with our metakaolin and reactive phases, resulting in that major pozzolanic activity. And with the platinum slag, it was giving off our favorable physical properties, with that forsterite and crystalline phases being present there. And then particle distribution was also necessary to be done in order to ensure consistency throughout our mixtures when replacing from the Portland cement and our river sand and introducing our platinum slag, to ensure that when we're replacing it, we're replacing with the same amount of fines and larger aggregates. The fresh concrete properties here, we witnessed that workability improved as we introduce our replacement levels or introduce our study materials, especially our platinum slag. It introduced our workability and our flow of our concrete mixture due to that ball bearing effect that I mentioned earlier on, which reduces the friction due to that spherical composition of that our platinum slag. And then the practical advantage of having this ball bearing effect would be that our water to cement ratio would then be reduced, and using less water within our concrete mixture potentially. Now, getting into the durability index results themselves, the key findings done for that 14-day analysis period was that throughout all our mixes, we identified that there were generally poor results, particularly due to that 14-day analysis, because we normally wouldn't do a durability performance for such a short period of time, but I'll explain as I go further for that analysis period. When we look at that M1, where it is the benchmark with the control mix, we saw having the highest OPI due to our combination within our mixture. And then our two design mixes, our M2 and M4, with the replacement levels, showed the highest permeability in terms of OPI, due to the fact that at this stage, early stage, the pore structure is still developing. It is still at a transitional stage. It is not yet fully matured. And then if we look at this, we see that the secondary cementing phases that are occurring here due to the metokaolin reacting with the portlandite is still not yet fully formed to create those secondary cementing phases and those carboluminate phases to refine our pore structure itself. The second of our index is the water subtivity along with the porosity. The findings here was that we were having, similar to the OPI, we were having generally poor results, which was high subtivity within our concrete mix itself. However, with the M4, it had the highest porosity, however, the lowest subtivity. And then if we were to interpret this result, we'd see that due to that higher porosity and lower subtivity, the pore structure is in a transitional state. Although it is not fully refined with those carboluminate phases, however, it is no longer interconnected capillary pores. So the transmission of water is no longer being permitted within our concrete mix, within our sample. And then we ended off with our chloride conductivity index there, where we saw that there was a progressive improvement when we were replacing our study materials in our concrete mixes. So what we found here with the M4, it showed the best performance in terms of chloride conductivity index, which means it was resisting our chloride conductivity. Now, this was kind of confusing because now with the other specimens, with the other tests, the subtivity, also the OPI, we were having poor results, but the chloride conductivity was generating much better results. This was due to the fact that the physical structure, pore structure, is still in a development stage. However, if we look at the chemical microstructure, we're already enhancing or witnessing our chemical benefits due to introducing our limestone calcinite clay. So this was verified with our microstructural analysis, the TGA, which showed that at that early stage, our LC3 is being consumed, is consuming the portlandite to form our additional cementing phases, supporting what I was saying that and at that early stage, the portlandite is still being consumed, so we're having that temporarily increase in pore structure. However, for the fact that we're already developing our carboluminate phases, the other ones are binding our chemical ions and restricting that ingress of chemicals within our concrete mixture itself. So with that M1, as I had said, it is at moderate level where the cementing phases are being generated in moderate level, and then we increase as we go with the replacement levels. And then closing it off with what we really see the research to prove is that at that 14-day period, we are still at a very much transitional stage, so we cannot get very much conclusive results. However, what we do find, what we do see is that the physical microstructure, as I said, it's at a transitional state. It is developing in terms of OPI and similarly with the subtivity. However, with the chemical microstructure, we are already seeing the benefits of introducing our LC3 also in our mixes there, with the chloride binding the mechanism of our chloride ingress. So that disconnection, like I had said, with the subtivity and OPI having poor results when we're replacing our study materials, they are showing poor results, but when as soon as we get to the chloride conductivity, we're finding good results. It's showing that at that stage, we are already, as much as at an early stage, we are finding that our chemical microstructure has already developed very much. And then to conclude the study, I then deemed the replacement of concrete paving blocks with our study materials, LC3 and PS, to be promising as a viable, sustainable alternative. The reason why I was saying promising is because the results, unfortunately, were not as conclusive as we would have wished them to be. However, we were seeing that there were some sort of benefits by introducing our materials within that concrete mix itself. And then just looking overall in the research and its environmental benefits, as I mentioned, that we introducing our limestone calcinite clay, we are reducing our carbon emissions compared to using Portland cement. And then introducing our platinum slag waste, we are diverting what was normally directed to our traditional landfills into something that can be recycled and used as an infrastructure asset. And then looking at our social benefits here, we are looking at our lower material costs, the potential of lower material costs, and also supporting South Africa's circular economy and recycling. What I said was deemed once as an environmental liability, that slag waste, into an infrastructure asset. And then just to close off, the research limitations and the recommendations here, as you would anticipate when doing research, a lot of things can go south, of which I did find during the semester carrying out my research. That is why I stuck with that early age analysis, which I had stated that you don't typically do durability performance analysis on a 14th day. You never. We're talking about 28 days up to 90 and even more. That's when we're talking durability. However, due to those unforeseen circumstances, I had to make something out of my research, of which I then decided to reshuffle my objectives and really look at the development stage, at that early stage of our concrete mixtures. And that limitation itself influenced the number of replacement levels I had, that 15% and 45. Then I couldn't really find the optimal dosage of our replacement level because it could be lying in between that 15 and 45%. However, we were deeming our result as promising as we had seen some of the benefits. And just to close off, the microstructural defects were just some of the limitations we would face in the lab. However, our results were recalibrated to suit our analysis. Thank you very much for your time and attention.
Thank you very much, Michelle. That was a very insightful discussion on concrete. So, yeah, from my side, I actually also do some research in concrete. So I also had some comments that I wanted to share. But in the interest of time, we can only take some questions from the judges. So let's let the judges ask some questions and then, proceed to our next one.
Thank you very much for that presentation. I enjoyed right there when you're covering your limitations, the honesty and that cautious optimism that was attached to your limitations. I only have one question. It's a very chemically convincing idea, and I'd like to find out, considering that your platinum slag waste has different, let's say, chemical and mineralogical properties against your natural aggregates.
Yes.
Has the study, or have you evaluated risks such as your alkali silica reactions, or like your concrete cancer, as they call it, under South African conditions when you're combining this with your LC3? I know it's such a long-term type of a thing, but and I do, I've seen under your limitations you've captured something, but nothing was talking to this. But is it something that you've considered, or at least taken cognizance of moving forward?
Yes, yes, sir. Thank you for that question. I am aware of that ASR investigation that should be done as part of our durability, but it was not included in part of my research as a whole. So what I was really focusing on there was just the aspects that I did mention here, which were the physical microstructure and the chemical, however, excluding that allyl-silicate reaction. So I did not include it in my research, sir. Yes.
Thank you so much for a great presentation. I think I've got a question on the cost or economics part of it. I saw you've indicated in your presentation that there will be cost savings.
Yes.
I just wanted to check whether you've perhaps looked at your production cost versus your production cost versus the actual, like what cost you'll be saving between your production cost and the fact that you'll be using waste material from the platinum.
From the platinum,
Has
yes.
there
yes.
been a comparison in terms of that?
No, the full financial comparison was not carried out. However, the statement is coming from or stemming from the benefits of introducing our workability and the potential to reduce our water content within our concrete mixtures, and also looking at recycling our materials within the industrial sector. Instead of mining or taking our natural river sands and using it as a normal aggregate within our concrete mixtures. So just to, a simple answer for that one, no, not a full financial study was done, and evaluation was not done to carry that out.
Thanks.
Yes, yes.
We have one more question from the judges, and then we'll close the floor. And then if you would like to ask further questions, you'll deliberate in the comfort break later on.
Thank you. I was going to hold my breath, but I see no other judges wanting to ask a question, so I'll take the opportunity. It's an unfair question, right? Because you haven't looked into that aspect in your experimentation and your research. But the bulk density of slag is so much higher than your normal aggregate. So from a commercial perspective, do you think it will be feasible for that slag to be taken from the mines to wherever it is required during construction? Because I know Sanral has looked into slag as an option here, and that was one of the major challenges.
Okay. In all honesty, I have to say, as it being one of a very rare study to carry out with the platinum slag itself, so I wouldn't really have a definite answer to say it would be feasible to. However, I would say, since the study is still being initiated, me carrying the study out was just to see the feasibility of it being introduced within the sector itself, not as a whole, as in that implementation sense, being implemented within the industry itself, just to see in terms of durability, are we really getting that comparative performance? So yes, just to put it in that sense, no, not a full feasibility study. I can't give a definite answer for that one.
I just want to commend you on how failure and limitations didn't stop you from actually continuing with your research, but you turned it into something positive. I think we can all learn from that.
Thank you very much.
Thank you.
Thank you very much.
Thank you very much. I think that was a round of applause. All right, now we can go to our last presentation before the comfort break. Sorry about the slight delay, that we should have been on a break now, but the last one that we'll go to is from Wits University, where we have two presenters. As usual, I think that's their signature knock everyone out the park move. Two presenters, Chiameka Eroka and Akanani Mbiaka. And yeah, so Akanani's favorite book was The Alchemist, with a quote, "Trust the process." So I believe that one was representing the team. And I'd like to bring them forward to begin their presentation, which is on a performance-based assessment of polyionic liquid concentration limits in reverse osmosis membranes for water treatment. Mic and lapel. Who would like a mic? Who would like a lapel? Let's do this. You can use mine, yeah.
Good afternoon. My name is Akanani Mbiyake, and I'm here with my group member,
Chiamaka Iraka.
We will be presenting our investigational project titled The Performance-Based Assessment of Polyionic Liquid Concentration Limits in Reverse Osmosis Membranes for Water Treatment. Many countries in Africa face water stress, mainly due to rapid population growth, urbanization, and climate change. In South African cities, rural to urban migration and immigration further increase water demand. Most proposed solutions to combat these water shortages have focused on improving surface water availability, primarily through solutions like building dams, as well as implementing water conservation and water demand management initiatives. However, the need for alternative strategies to combat these water shortages has been recognized, and a transition toward implementing these strategies is now evident in water resource planning. The National Development Plan and the National Water and Sanitation Master Plan highlight the need to optimize South Africa's water resource mix and promote the development of non-conventional supply options beyond traditional surface water sources to ensure long-term water security. Long-term, alternative strategies include better use of groundwater, stronger water demand management, expanded water reuse, and desalination. And this project, desalination, was explored as the alternative supply strategy.
Water desalination is the process of removing salts and other minerals from seawater or brackish water to make it suitable for human use. Several methods exist, with thermal techniques like multi-effect distillation and multi-stage flash relying on heat to evaporate and condense water, but these require a high energy input. Due to the global need to conserve energy, reverse osmosis has become the dominant approach. Its principle is simple but effective. By applying pressure, saline water is forced through a semi-permeable membrane, leaving salts and impurities behind. Today, reverse osmosis accounts for nearly 70% of the world's desalinated water supply. However, it is not without flaws. Arguably, its biggest flaw is membrane fouling, wherein particles, microorganisms, or other materials accumulate on or within the membrane, reducing its efficiency. To address this, researchers have explored the use of polyionic liquids into membranes in order to improve their structural strength. Ionic liquids are charged compounds that remain liquid at relatively low temperatures. Polyionic liquids are polymers that integrate ionic liquids into their structure, which combines the chemical stability of ionic liquids with the structural integrity of polymers, making them suitable for improving reverse osmosis membranes. Due to this, researchers have conducted many studies involving the effect of polyionic liquids on membranes, and this research has shown us that excessive amounts of polyionic liquids can actually be detrimental to membrane performance, as it compromises the selectivity of the membranes. However, all of this research focuses on remaining safely below that upper limit. In contrast, our study deliberately approached this threshold, aiming to identify the precise point at which performance begins to decline, which is a boundary that has not yet clearly been defined.
This leads us to a question. How much PIL can be incorporated into reverse osmosis membranes before performance begins to decline, and what structural changes might occur as a result? To find an answer to this question, our objectives included fabricating reverse osmosis membranes with varying percentage rates of our PIL of choice, characterizing the surface properties of these membranes, and testing their performance to determine how efficiently they function under operating conditions. To achieve the objectives of the project, the methodology was divided into 3 parts: membrane fabrication, membrane characterization, and performance testing. For the membrane fabrication step, 2 processes were carried out. First, casting the support membranes, and second, forming the polyamide layer, which is also known as the active layer, on top of the support membranes using interfacial polymerization. The first step was carried out by dissolving and mixing polysulfone pellets in N-methyl 2-pyrrolidone. This solution was then poured onto a glass plate, and 100-micron films were cast using the casting knife film applicator shown on the screen. To form the active layer on top of the support membranes, these membranes were first immersed in an aqueous solution of M-phenylene diamine, and then in an organic solution of hexane and tramezoyl chloride. This table shows the composition of the membranes. Membrane 1 served as the control, while the PIL was incorporated into membranes 2 through to membrane 6. The amount of PIL was progressively increased from membrane 2 to membrane 6, while the other membrane components were kept constant. To understand how these compositional changes affect the membranes, membrane characterization was carried out. Membrane characterization involves studying the properties and behavior of membranes, which is essential for their efficient application and for determining the most suitable operating conditions in separation processes. For characterization, we measure the water contact angle, which is the angle formed between a water droplet and the membrane surface. This indicates surface hydrophilicity. We also determine the porosity and characterize the membranes in terms of their surface properties. To evaluate membrane performance, the conductivity, total dissolved solids, and the pH of the filtered water was measured, and then the salt rejection and water flux of the membranes was determined.
After membrane fabrication, several notable observations were made. Firstly, the membranes exhibited a smooth surface texture, which is a desirable quality as it suggests uniformity during the fabrication process. However, as can be seen in the image alongside, weak spots were observed along the edges of the membranes, likely attributed to the formation of air bubbles during the fabrication process. In terms of handling, the membranes demonstrated a generally good structural integrity, and they could be lifted up without deformation, which was a sign that they possessed the sufficient flexibility and robustness for practical applications. These favorable mechanical characteristics are also expected to hold true in larger industrial productions, as they depend on intrinsic chemical properties and not the dimensions of the final product. Finally, after undergoing interfacial polymerization, the membranes did not display any visible physical alterations. This lack of observable change on the surface indicates that the interfacial polymerization process proceeded uniformly, imparting the expected functional properties on the membranes without affecting their physical appearance.
Turning our attention to the characterization of the membranes, several important trends were observed. The water contact angle results showed that all the membranes were hydrophilic, with values below 90 degrees confirming their suitability for desalination. Interestingly, the introduction of a PIL produced a nonlinear effect on hydrophilicity. Small additions of the PIL initially increased the contact angle, but further incorporations in membranes 3 and 4 significantly reduced it, indicating improved hydrophilicity. This aligns with literature showing that lower contact angles are associated with better antifouling performance. However, as seen in membranes 5 and 6, high amounts of the PIL increased the contact angle. This was likely due to structural disturbances in the active layer, where excessive PIL can create voids and expose the more hydrophobic support layer. Porosity measurements further confirmed the complex influence of PILs on membrane structure. While most of the membranes had a moderate porosity, membrane 1 stood out with a value above 100%, which is not physically realistic. This was likely due to membrane swelling or experimental variation. Overall, the lack of a consistent trend suggests that factors such as swelling behavior and structural distortion play significant roles in determining porosity. Microscopic examination of the membrane surfaces showed that the addition of the PIL generally reduced the size of the openings, which enhances selectivity. A distinct defect was visible in membrane 4, where a large irregular opening suggested non-uniform interfacial polymerization. Such defects can compromise membrane performance by allowing greater solute passage. At high PIL loadings, as in membrane 6, the openings became larger, indicating structural instability caused by excessive PIL.
Moving on to the results of our performance tests, it is important to note that the seawater that we used was completely raw, with no pre-treatment being done. This explains the relatively high values of total dissolved solids and conductivity levels that we observed. It should also be noted that salt rejection and water flux are calculated permeate properties. As a result, raw seawater does not have these values. Despite all of this, these results still remain highly reliable as they provide a clear and consistent basis for comparing the performance of each of our membranes. Starting with raw seawater, we can see that it has a very high conductivity of nearly 60,000 microsiemens per centimeter, total dissolved solids concentration of nearly 30,000 milligrams per liter, and a pH of 8.7. All of these values are expected as seawater naturally has a higher amount of salts. When we move to the control membrane, labeled membrane 1, we see a small improvement. The conductivity drops to just above 51,000 with a calculated salt rejection rate of just above 11%. This shows us that while the membrane is limited, it is working with limited effectiveness. Comparing this with membranes 2, 3, and 4, and we notice some interesting patterns. Membranes 2 and 3 have nearly identical performances in terms of salt rejection, with membrane 3 performing slightly better and achieving almost 20% salt rejection. Membrane 4 has nearly identical performance to membrane 3. Additionally, the water flux of these membranes is increasing with a positive trend as it goes from 0.00024 meters per second in membrane 2 all the way up to 0.00032 meters per second in membrane 4. The standout performer from this study was membrane 5. It showed the highest salt rejection rate of 28.15% while reducing the conductivity to just above 30,000 and reducing the total dissolved solids to just above 21,000. This suggests that membrane 5 is the most effective amongst all the membranes that were tested. However, this peak in selectivity comes at a cost as it has the lowest water flux of all the observed membranes. When we turn our attention to membrane 6, we can clearly see that performance drops off with salt rejection falling back to around 18% and the conductivity rising in comparison to membrane 5. This shows us that previous findings showing that excessive PIL can disrupt membrane performance is true. The reason for this is that the excessive PIL disrupts the membrane's pore structure, making it less selective. So in other words, instead of enhancing rejection, the amount of PIL added starts at a certain point will start to compromise the balance between permeability and selectivity. In conclusion, our results confirm that there is an optimal concentration of PIL at which desalination performance is maximized. This optimum is observed at approximately 1.4 percentage weight, beyond which further PIL becomes counterproductive. Beyond the technical findings, this research also has some significant socio-environmental implications, as by improving membrane selectivity and performance while maintaining reasonable permeability, PIL-enhanced membranes can make desalination systems more effective and energy efficient while also becoming more cost-effective. Reduced fouling and improved salt rejection will lower operational demands, which can extend membrane lifespan. This, in turn, will support more sustainable water treatment processes. Ultimately, advancements like these contribute to making desalination a more viable solution for water-scarce regions, helping to improve access to clean water, particularly for underserved and vulnerable communities, while also reducing the environmental footprint associated with large-scale water purification.
It is recommended that future investigations incorporate the PIL into the membrane support solution rather than adding it after the support membranes have already formed to better improve integration. It is also recommended that larger membranes be fabricated and tested to better align the results with what is expected in commercial desalination plants. Thank you.
All right, thank you very much, guys. That was a very insightful discussion. Again, due to time constraints, we're going to let the judges ask some questions, and then you guys will just answer them, and then we'll proceed. So do the judges have any questions they'd like to ask?
Hi, thank you for that presentation. It was quite good. I think the concept's quite good as well. initially I wondered, where did you get the membranes from? And then I saw that you fabricated it. And then with research like this, are you confident that the fabricated membranes were of consistent properties? Because if they weren't, your PIL conclusions are questionable.
Okay. So to answer that question, we are 70% confident, and we think that if we had access to scanning electron microscopy, where we'll be able to sort of see the full physical characteristics of the membrane, then we would be fully confident. However, we used microscopy, so we were just able to see the physical surface of the membrane.
So my question is along similar lines as my colleague. My question was going to be, is there only one type of membrane for these reverse osmosis? Or are there different types?
There are different types of membranes in terms of like the base support membrane. There are other scale-in solutions that are usually added to membranes to give it different properties. It depends on like what you're going for or how refined you want the water to be. It depends it also depends on what type of water you're desalinating, whether it's seawater or brackish water. So there are different types of membranes, but all of them can be enhanced with PILs. There's no like limit, or there's no type of membrane where this wouldn't be applicable.
Okay, thanks.
All right, do I have any other questions from the judges? If not, we'll take one question from the group before we go for our comfort break. All right, no. So if there are no questions, thank you very much, guys, for that presentation. This is exactly what Prof was talking about engineering is making things happen. We can see that you guys are solving practical problems that we all face on a daily basis. So well done on that, guys. Thank you very much. So at this moment, we're going to go off to a 10-minute comfort break, and then when we come back, we'll have 2 more presentations, and then the judges deliberate, and we close off our program. So if you guys need to go to the bathroom, if you'd like to go get a quick snack outside, let's make it 5 minutes because we are behind time. So it's just a quick in and out, guys. So no...
So there'll be 2 boys and are you done? Are you leaving? No, so everybody has to do it together then.
Oh, we must do it.
Yes.
You can even start now so you can show them.
Yes.
So what she says was
So we're not capturing those questions.
on number 5.
Let's see how what time.
Thank you so much. Thank you for welcoming us here.
No, it's great to have you here.
Thank you very much.
Great honor for us.
Thank you very much.
Anytime. You're doing a great job.
Interesting how
Yeah, he is. Oh yeah.
all this research is very clinical focused.
I'm an alumni of here. I haven't exposed you, Chief, because I don't want to show bias, but talks of next. Talks of good. It comes through.
A macro level, you don't give us.
Well, it was quite impressive.
I don't know, look at the judges' deliberation.
products.
So you're number 4. What's your total for your first contest? Number 2? Speaking to, and you got to be sensitive because they're starting their careers now. You can't
don't want to break them down.
You don't want to break them down. So the guy with the materials, because you do pavements, so I had so many questions, but then I also realized just leave it on it.
So like my question also on the UJ one, on where were these samples taken? You didn't kind of get what I was trying to get at, but you don't want to break the guy down.
Yeah, so
you just accept it. Yeah.
I like doing Excel interviews because they just ask. There's no love lost.
Brutal.
Yeah, but I try not to be unfair with the guys, but they're dangerous guys. You can see guys who are dangerous.
In what sense? What do you mean?
Excavation tips.
Oh, okay.
They're just so they're cheap engineers that they sell quite high ranking, but they told me 10 minutes, but I think it's
15.
15. But they told me 10-minute presentation, 5-minute questions.
Yeah.
Do you have your totals? Do you have your totals? Not yet. Okay, when you're ready, you tell me.
Because we don't know what to do because scholars are swimming on Monday. I'm waiting today.
How many mics were there? Yeah. Oh, four, just four. Because I see one. And I think he can sort them out. Because the switching off does take long. So I think if we just keep the one on, he can like mute it. So it's number one, number 4, 5, and the one with the judges. So there's no number 2. There was never number 2. I think that's them that muted it. We'll sort it out. Okay, so I'm ready to start. According to this, the lights off. But yeah. Oh wait, no, it's on.
Oh, you're going to give me totals for number 1?
Yeah. Start.
79.5, yeah.
Alright.
Second one is UJ.
51.
What's the cable like you can plug into the laptop? Alright. So I think we can proceed, guys. I hope you guys are feeling well refreshed and ready for the final 2 presentations of the evening it is now. So yeah, our next presentation we're going to have from William Pierce from Stellenbosch University. And William's favorite book is Finding Endurance. And his favorite quote is, "Where there is a will, there is a way." So I'm sure to get all the way from Stellenbosch to here, there was a will and a way. So William Pierce, could you please come and present for us on rainfall-driven microbial pollution and health risks at Strand Beach. William Pierce. Mic on.
Thank you very much. Good afternoon, everybody. My name is William, and I'm here to present my thesis titled Rainfall-Driven Microbial Pollution and Health Risks at Strand Beach. Coastal water quality is critical to human health and environmental integrity. Section 24 of the Constitution states that everybody has the right to an environment that's not harmful to their health. The constitutional guarantee extends to coastal environments where recreational water quality is becoming a major public health concern. Beaches are one of the most popular places for people to enjoy and interact with the environment. Swimmers and surfers enjoy the waves, children play in the shallows, and the local economy also depends on tourism that comes along with beaches. The community has the constitutional right and the economic interest to a clean and safe coastal environment that is not harmful to their health. Strand Beach in Cape Town is one of the favorites for recreation, but over the past few years there have been really poor water quality tests sampled there, especially after rainfall, and there have been a number of illness cases also recorded. So this brought me to my topic. The City of Cape Town tests water quality there daily, so people still get sick, and people ask, well, why is this? The problem is the lag time that the tests have. They test, they go to the lab, and then only a few days later you get the results, and exposure's already then taken place, even if the water quality is really poor. We also don't really understand the rainfall-pollution relationship very well, and the City of Cape Town advisory to avoid swimming after rain, and this is quite vague. There's no real-time risk information available at the end of it. So my research aimed to provide a holistic overview of the water quality situation at Strand, and through the objectives listed, I wanted to answer the following questions. Why does pollution spike? Who is most at risk? And when is the water actually unsafe? And then also, what can we do about it? So some key literature insights that I came across in my research was that water quality is highly driven by rainfall, especially in urban areas. And so yeah, the rainfall is a main driver of pollution, and this is also highly site-specific. So independent projects are required for different beaches. And the current monitoring systems are insufficient because of the lag time that I mentioned. And then also, not just because I'm a surfer, but because I found it in literature, surfers are particularly vulnerable. And this is because in Cape Town, we get cold fronts in winter, and with cold fronts come the good waves, the big swell, and surfers are often in the water for long periods of time with lots of head immersions. So I focused on surfers in my study. And then I also found that a quantitative microbial risk assessment, or QMRA, is a proven framework, and it lets us translate bacteria counts into actual illness probabilities. Then both E. coli and enterococci are accepted fecal indicator organisms. And to explain fecal indicator organisms, where these little microbes are, they show that feces is already also there. And along with the feces obviously comes with harmful germs and pathogens. And at the bottom here of this table, I've just included some percentile thresholds for the acceptable concentration levels of enterococci in recreational waters. So just keep in mind that sort of range, the 185, 200 values there for when we get to the findings section. Just a quick overview of my methodology. I used a mixed methods approach because of how complicated this whole situation is. So I obtained 226 daily water quality samples from the City of Cape Town, dating from September 2024 to September 2025. And I matched these with daily rainfall data that I collected from the South African Weather Service. And using Excel for statistical analysis and visualization, I could identify some patterns. To then validate these patterns, I sampled 4 different locations at Strand Beach, and this was for E. coli using DIY test kits. And I also targeted a cold front event with rainfall, so I tested before, during, and after the event to get a nice range. And then I did a QMRA risk assessment using the World Health Organization framework with bacteria counts from the historical data, and then I used a Monte Carlo simulation with an exponential dose response model to calculate the probability of gastrointestinal illness. And this quantifies what the pollution levels actually mean in terms of health. Combining all 3 or all different sections of my project, I could identify potential sources of pollution, and I'll get to that later. So what do the numbers actually mean? On the top left here is a summary of the whole entire data set, and we're looking at enterococci concentrations. So this is the historical data I got from the city. You can see the averages are not super high, but the Strand Pipe surfing area is almost double the swimming area, and this is because it's located close to the river mouth. But what the problem here is that those maximums are very high, 4,400 and 19,000. That's almost 100 times over the safe limit. So now we can break this down by season, and this is where the pattern becomes crystal clear. In summer, the surfing area at Strand is well within the safe limits, but in winter, Strand is far above the threshold, and that's poor or unacceptable in terms of the South African standards. We must remember that Cape Town experiences winter rainfall, so that's quite obvious that the rainfall has a large effect. And then, so now over on the right-hand side of the slide, I've summarized the effect. I found that heavy rainfall, more than 30 mils, resulted in quite dangerous spikes, and also the duration of the spikes were quite long, much longer than Cape Town's 24-hour advisory to avoid the water. So it was dirty for 2 or 3 days. Lesser rainfall caused a shorter duration of contamination, and then minor rain had little to no impact. Now, moving on to my field work, the graph on the left shows the E. coli concentrations at the 3 different time points that I mentioned before, during, and after a cold front. So the first section is the river mouth. On the top of the photo there, that's where I tested, and it shows consistent contamination far above the threshold. So this is a logarithmic scale on the y-axis, and you can see it's far above that 185 to 200 range. And this confirms the river as a constant pollution source. Moving on to the second location, shows what is exactly what I was looking for, the spike during the rain. So the sea became very, very dirty when I tested during the rain, and this confirms the rainfall's impact on the quality of the water. Then there's something striking. I tested the stormwater outlets running onto the beach, and they were very, very dirty, as you can see at those 2 big columns there. The bottom petri dishes here were from the river and the sea, and the stormwater one was just completely overgrown. It was quite gross, actually. But then when I went back for the third test, the sand had covered that stormwater drain, and I tested another one just down the beach, and it was also very, very polluted. I wouldn't want my child swimming in that. Okay, on to, not that I have a child, by the way. On to my risk assessment. So this equation here is what I used, and it's an exponential dose response equation, and it shows the probability of gastrointestinal illness after one single surfing session. And it takes into account the dose, the infectivity parameter, which I got from literature, and the illness to infection ratio, which is recommended by the World Health Organization. So yeah, the winter surfing at Strand Pipe is quite concerning. The 95th percentile, which is the worst winter conditions, shows that there's a 23% chance of getting sick from a single surf. And now we need to compare this to the standards. So the South African guidelines tell us that any risk above 8.5% for the 95th percentile is unacceptable for recreational water. So my results are almost triple that, which means roughly 1 in 4 surfers during peak winter contamination will experience gastrointestinal illness. So this isn't speculation, this is quantified risk based on actual measured contamination levels. Now moving on to the potential sources in the area, there are several interconnected sources that are driving the poor water quality, especially in winter. So obviously the Lawrence River acts as a conduit for all the pollution from upstream, which includes urban areas, informal settlements, and agricultural land. So this contamination is carried downstream and released straight at the river mouth, which is very close to the surfing area at Strand. So yeah, the surfing area experiences worse contamination compared to the swimming area, which is just down the beach. And that shows in my field sampling results as well. Just an interesting one, the sewage pump station located at the river mouth failed in July 2025, and it coincided with some very high pollution levels recorded. The sewer network in Strand is also a problem. The sewer line is a gravity-fed sewer line which carries flow from the whole of Strand down to that pump station. And it has a history of blockages and spillages. And it collapsed in February 2025, and it caused a major overflow with beach closures. And heavy rainfall obviously adds to the stormwater and the gravity-fed sewer system. And this can overload the pump station and cause further leaks. On top of that, the stormwater outlets along the beach, including 2 very close to the main swimming area, those 2 that are tested, carry high levels of bacteria. And this is likely from leaking sewage, urban runoff, and areas with poor sanitation, such as that one I highlighted there in the picture. And finally, the Eerste Rivier, which enters the ocean less than 10 kilometers away, can bring additional pollution. This is where the pump station pumps all of its sewage to, and that's located right at the river mouth. So any spillages or problems there, the sewage can go straight into the ocean. So what does this all mean? Well, I confirm that rainfall is a major driver of coastal pollution, and that it lingers in the sea for quite a while, depending on the intensity. And the City of Cape Town's 24-hour advisory is just not enough. It needs to be communicated a bit better to the public. Surfers also face a very high health risk, especially in winter where they are active and where contamination also peaks. And the risks they face are much higher than the acceptable standards we spoke about earlier. The old infrastructure at Strand worsens the impacts. The pump stations, sewer lines, and stormwater systems aren't coping with the storm events, and this is evident in the testing data. And real-time warnings are needed. The current testing lag leaves people exposed to high levels of pollution without any warning. In summary, Strand Beach has a serious quantifiable water quality issue that needs urgent attention. So a few humble recommendations from me. First of all, when I tested the stormwater drains, there were no warning signs. And when I got the results, I was blown away that it can be that polluted, and any family or child can go swimming without knowing the risks. So that's my first one. And then obviously we need to look at the infrastructure. Maintenance is required, maybe even upgrades if there are some sewer lines in a bad state. And the city should also ensure that there is a rapid response procedure to fix any blockages before they can cause too much of a spill. And then there's current gaps in the data, so a continuous and and more thorough monitoring system should be put in place. The city doesn't test on weekends or on public holidays, so there are gaps where it would be nice to see some better data. And the most beach users don't really know about this 24-hour advisory set out by the city. So I think the city should focus on communication also with surfers to tell them their elevated health risks. And they should set out a more in-depth recommendation based on those findings that are found, with high rainfall resulting in multiple day pollution. So they could say something like, heavy rain yesterday, avoid the water for 3 days. And this is actionable guidance people can use. And then in the informal settlements, it's quite obvious if there was better sanitation infrastructure, there'd be less runoff and less polluted runoff. So some areas where there can be some future research done. I spoke about expanding sampling. You could do daily sampling, more locations to understand the situation a bit better. And then acquire rainfall data at Strand itself. I used a station a few kilometers away. It would be better if we can get rainfall data from Strand. And then microbial source tracking can identify exactly where the pollution is coming from. So that's another one people can look at. And then people can deepen the QMRA models to look at different types of people, elderly, young, who are super vulnerable, and maybe have a look at some different pathogens as well. And then the big one for me, which I think would be very beneficial, is to explore a live automated risk prediction model. So I vision something that has a look at the current rainfall, the rainfall in the past few hours, and then gives the public a sort of risk estimate of how bad they think the water is going to be. But this, obviously, it needs better data to be able to work. So the technology exists, and the relationships are quantified. We just need to implement it. So my research quantified how rainfall affects pollution at Strand Beach, clearly defining the health risks of entering the water after storm effects, especially for surfers. And it identifies specific practical engineering measures and establishes a framework that could support real-time public warning systems. Ultimately, it uses engineering to help uphold the constitutional right to a safe and healthy environment. Thank you.
Thank you very much, William. So we're going to open the floor to questions from the judges. Yeah, the one that I had was I wanted to ask about how things were looking last year, August, because I was there and I came home feeling a bit funny. So there you go. So I need to, I just need to make sure if that was the cause. But yeah, judges.
You've just ruined vacation in Cape Town for me,
yeah.
because ignorance was bliss. I'm just wondering, I'm seeing actually an opportunity in what you've said. Maybe there could be like test kits in some form that can test the water like in real time before you actually get in the water, like a dipstick or something. That can be developed and commercialized, just so that people can know how safe the water is, because we take it for granted that it's safe.
Yeah, no.
Yeah.
The ones I used took 2 or 3 days to see results, but that would be hugely beneficial, yeah.
Yeah, like a swimsuit that if you get in, it turns blue, you jump out, you know, something.
Yeah, exactly. That's why I was trying to highlight the need for a real-time estimate. Yeah.
Just 2 quick questions. Did you look at the ways of how do you treat this problem at source, you know, within the wider catchment? You know, is there ways of treating it at source? And my second question, on your logarithmic curve, I saw it on your second stormwater outlet, the post-event contamination was much higher than the pre, whereas on the other one it was exactly the opposite. What were the reasons for that?
Were those the 2 stormwater
Yeah,
outlets?
that's right, yeah.
So the first 2 time points that I tested were on the first stormwater outlet, and then when I went back for the third time point, sand had covered it. So I then went to the second location to test after the rain, yeah.
My first question.
Can you please,
Yeah.
Yeah, it was more related to can't you treat the pollution at source more than at its final destination? Because
Yeah, so
that's
that
probably will be a more effective way of looking at it.
100%, yeah. That's fixing the sewage infrastructure and then also providing better sanitation for the informal settlements. Yeah. But the situation is quite dire. Like, it's going to require a lot of investment.
All right, I think we can take one question from the audience. So let me just get you a mic.
Thank you. Thanks for the presentation. And I think I have to first take a disclaimer. I was a microbiologist before coming
can I just check this
to
mic?
engineering. So I've got two questions for you. Why did you select a method that takes 3 days to give you results for measuring E. coli and enterococci? Because there are plenty of techniques and even commercial kits that will give you results the morning after. So you're looking at like an overnight.
It's what I had available to me at the university. Yeah.
Okay.
There were those collie-scan test kits for E. coli. Yeah.
No problem. I was just curious. Second question that I have has got to do with why only E. coli and enterococci and nothing from the other classes of communicable organisms. Thank you.
Okay, so the city only had enterococci data available for me. So it's just what I had to work with. And then the E. coli tests were easy to use. I could do them by myself. And I had availability. Yeah.
Thank you very much, Olympius.
Thank
that
you.
was a very good presentation. All right, now, last but not least, we'll go to our final presentation from our host presenter. Saice Dairam is from the University of Pretoria, and I didn't expose this earlier, but I'm also a UP alumni, so yeah, we're looking forward to some great things from Saice. And her favorite book is The Great Gatsby, with her favorite quote being, "The content of a book holds the power of education, and it is with this power that we can shape our future and change lives." So Saice, thank you very much. You'll be presenting on the performance of concrete incorporating a high percentage of fly ash and slag. Yeah, perfect.
Right now, somewhere in the world, concrete is being placed. And at that very moment, carbon dioxide is being released into our atmosphere. Not from cars, not from planes, but from the very material that built our cities together. Concrete built civilization, but cement is quietly costing the planet. The question engineers face today is no longer, can we build it strong enough? It is, can we build it responsibly? Good afternoon, everyone. My name is Saice Dairam, and the title of my research is The Performance of Concrete Incorporating High Percentages of Fly Ash and Slag. South Africa and Europe produce comparable levels of CO2 emissions, but Europe is 8 times larger. That means every building, every road, every ton of cement we pour leaves a disproportionately large carbon footprint. But this study asks a surprisingly simple question. What if the solution to more sustainable concrete lies within our waste? So let's start with the basics. What is fly ash and slag, and why does it make sense to use them in concrete? Fly ash and slag are classified as supplementary cementitious materials. These materials are used as common partial cement replacements for ordinary Portland cement. Fly ash is a byproduct of the coal combustion process, and Eskom is our primary electricity supplier in South Africa. That means Eskom is also responsible for about 85% of the fly ash produced in the country. Now, here's the problem. Only 7 to 10% of this 85% actually gets recycled for construction purposes. Slag, on the other hand, is a byproduct of the ferrous metal industry. South Africa produces approximately 4.7 million tons of slag every year. With numbers like these, there's a clear need to make use of our waste materials, not just for the sake of engineering innovation, but for the sake of the environment. By incorporating these materials into our waste, we can reduce the amount of waste going into our landfills, lower the carbon footprint associated with the cement industry, and build more sustainably overall. The research presented today investigates the performance of tri-blended concrete mixtures with up to 80% cement replacement using fly ash and slag. The aim is to determine whether an environmentally and economically suitable mix can be developed for commercial applications without compromising on strength or durability. Now, the central question driving my research is whether the level of adoption in South Africa is truly sufficient. Is a 30% cement replacement rate merely a convenient benchmark to secure a Green Star rated building, or does it actually meaningfully contribute to sustainability in our built environment? This prompted me to interrogate a deeper question. What more can we, in South Africa, realistically and responsibly do to optimize our concrete systems beyond the minimum requirements? My work, therefore, not only seeks to evaluate the current practices, but to also challenge the limits of what we consider acceptable progress in sustainable construction. The scope of my study included using a central composite design within the response surface methodology framework with varying cement replacement rates of 0 to 35% fly ash and 0 to 60% slag. So what are these big words that I just said? So response surface methodology is a statistical tool used to see how different variables affect an outcome and how to find the best combination of these variables. In my study, we look at different proportions of fly ash and slag affect the performance of concrete and how they work together. The results of the central composite design is typically shown on a 3D surface plot, which is just a 3D graph that changes the outcome as the proportions change and gives you a range of results. To design the concrete mixes efficiently, a central composite design was used. This was a smart statistical method that allows us to get a range of results for the concrete mixes while only casting specific mix designs. So for those wondering how I got the mix designs from a square, each coordinate on the square corresponds to a specific mix design to be tested. The central point denotes the central mix, which was cast 3 times, and the corner and axial points captured the extreme and intermediate levels of cement replacement. A total of 11 mix designs were obtained from the central composite design, with the 12th mix containing no slag and no fly ash to serve as a reference. All cements were tested under SANS and European standards, allowing cements with low clinker content to be classified as CEM6s, a classification that has not yet been standardized in South Africa. The research evaluated the performance based on fresh properties such as workability and heat of hydration, mechanical properties including compressive and splitting tensile strength, and durability through oxygen permeability index, porosity, and carbonation. All tests were conducted under 2 curing regimes, a 25-degree water bath, and outdoor curing to simulate on-site conditions. The purpose of conducting such a range of experiments was to ensure that the results are evaluated comprehensively. This holistic approach strengthens the findings of the results and also shows its viability for real-world application. Workability was assessed using the slump test. From the 3D surface plots, it was observed that both fly ash and slag contribute to increased workability, although fly ash contributed slightly more due to its spherical particle shapes. So how did I get all of this from the 3D graphs shown on the top left? So when analyzing 3D graphs, we have to look at 2 things. We have to look at the gradient and we have to look at the color. So in this case, higher workability is shown by the warmer colors and lower workability is shown by the cooler colors. And we can see that as we increase fly ash and slag, it generally increases towards a warmer color, which indicates higher workability. The heat of hydration trend indicated that blended cement significantly reduced peak temperatures during casting, which aids in preventing thermal cracking during mass concrete pours. Compressive strength was tested at 7, 28, and 90 days for both curing conditions, and linear models with coefficients of determination ranging from 0.89 to 0.98 were developed. All mixes exhibited low early age strength ranging from about 7 to 35 MPa, followed by a notable strength gain up until 90 days. However, the mixes containing supplementary cementitious materials did not achieve higher compressive strength than that of the pure cement mix, which contradicted literature suggesting that fly ash and slag will enhance the long-term strength. However, a possible reason is due to the insufficient amount of cement available to react with the pozzolanic materials. Still, most of my mixes achieved around 30 MPa, which is perfect for typical home structures, offices, and other standard structures. Durability was assessed through accelerated carbonation, conducted in a carbonation oven set at 50 degrees Celsius with a 20% CO2 concentration rate. A phenolphthalein indicator, as shown on the video on the screen, was sprayed onto a freshly exposed concrete surface. Areas that turned purple indicated uncarbonated, highly alkaline concrete, while the gray or colorless regions represented uncarbonated zones with reduced alkalinity. This distinct color change allowed the carbonation depth to be clearly identified, with the boundary between the purple and gray regions representing the point to which the carbon had penetrated the concrete. So, to put this into perspective, carbonation plays a significant role in determining where steel reinforcement can be safely placed without being exposed to corrosion. So, if the carbonation front reaches the reinforcement zone represented by the gray region, it indicates a high likelihood of steel corrosion. In my results, the highly replaced mixes underwent full carbonation in comparison to the reference mix, Mix 12. However, it is important to note that carbonation simulates decades of penetration, often equivalent to more than 20 years. This allows us to meaningfully assess a long-term structural durability performance indicator over a shorter time frame. Embodied carbon, which measures the amount of CO2 during material extraction, production, and transportation, was also measured. The reference mix exhibited the highest embodied carbon, Mix 7, while Mix 7 had the most replacement and showed poor performance in terms of strength and durability. Similarly, the relationship between cost and compressive strength shows that both fly ash and slag contribute to concrete performance. As their proportions change, we observe a clear interaction over here in the green region, where approximately 30 MPa can be achieved at a moderate and cost-effective level. In a similar way, the relationship between cost and compressive strength reveals how these materials also influence the environmental impact of the mix. Once again, the green region identifies the optimal zone where embodied carbon is reduced without a major increase in cost. Together, these findings demonstrate the importance of optimizing the proportions of fly ash and slag to yield environmentally sustainable and economically efficient concrete. So, to determine the optimal ranges of fly ash and slag that yield environmentally friendly concrete, variables such as cost, embodied carbon, embodied energy, accelerated carbonation, and compressive strength at 90 days were analyzed. The results demonstrated that a combined replacement of 55% can reliably achieve a 15 MPa strength, while a combined replacement of 45% can achieve a 30 MPa strength. These findings suggest that moderate levels of cement substitution can maintain concrete performance while supporting sustainability in future infrastructure development. To put this in perspective, producing 1 cubic meter with a 45% cement replacement can reduce emissions by 180 kilograms of CO2. This is equivalent to driving a standard passenger car for about 800 kilometers. So why does this research matter, and what am I telling you? And what does this mean for the way we build in South Africa currently? At present, the EN 197-1 European standard permits cement replacements with up to 90% with fly ash and 95% with slag. Yet South Africa continues to operate within far more conservative limits, 65% and 40% respectively. Part of this hesitation stems from the fact that our fly ash is often unclassified due to its origin as a waste product, whereas European fly ash is generally of a higher, more consistent quality. However, there still is a significant middle ground, a space where South Africa can responsibly push its standards further. And here's the uncomfortable truth that I mentioned at the beginning. South Africa and Europe produce comparable levels of CO2, yet Europe is 8 times larger. That means our industry is being disproportionately cautious in comparison to our area. So the real question is, why are we not doing more? Why is the widespread inclusion of fly ash and slag still treated as an optional sustainability feature instead of a standard expectation? The research presented today has shown that slag and fly ash are economically advantageous, environmentally superior, and technically feasible. The mixes developed in the study are not niche high-end solutions. They are viable for everyday construction, from conventional buildings to mass social housing, not just for elite Green Star buildings. If we're serious about decarbonizing our built environment, then incremental change is no longer enough. The results show that we can do better. The choice is whether we choose to. Future research in South Africa will be essential to validate and expand these findings, further identifying concrete mixes that are both durable, cost-effective, and practical for real construction. But research alone is not enough. South Africa must move towards clearer grading standards for South African fly ash, introduce performance-based durability testing, and create incentives that promote higher supplementary cementitious material use. By strengthening our confidence in local materials, South Africa will not just follow global best practice, we can help define it. Ultimately, my research shows that we have both the capability and the evidence to reduce our concrete's carbon footprint. What we need now is the collective commitment to act. Thank you.
Thank you very much, Dan. Wait, before you go, yeah, could you please just open the floor up for questions by the judges? Ask the question.
Yeah, I was going to ask the same question with regards to the bulk density, but I really think it's an unfair question for her. I think you did brilliantly, and thank you for the presentation.
Thank you.
Thank you very much. Are there any other questions by the judges? From my side, I just wanted to ask, in terms of the accelerated carbonation tests, where you said that the ones with high levels of fly ash and slag experienced full carbonation, when were those tests taken? Like, was the test taken within that 7-day period, or was it taken later on? Like, when did you do the carbonation test?
I took an average of 7, 14, 21, 28, and a 36 day.
And 36
Yes.
days. And results were the same throughout?
It carbonated further every week, and then an average was taken to create the surface plots.
Okay, no, thank you very much. I think I can open up for 1 or 2 questions from the audience. Does anybody have questions related to this? I see a question on that side. I'll take this number 1. Do I press this button here?
Check the LCD.
It's off mute. It's off mute.
Good afternoon. Great presentation. I don't have a question, but it's more of a comment. I'll also get it connected with Dr. Kelly Reynolds.
No.
Okay.
Sorry.
Yeah, she's done some excellent work around more or less the same area. So I think I'm based at Kusile Power Station, so we've done something a little bit closer to what you're doing.
Thank you.
Thank you very much. And then we'll take one comment from, can we just let him check the microphone?
Doesn't have to be serious. I just wanted to say I love the purple line combination.
Oh, thank you.
Thank you very much, Dan. That was a very good presentation. And yeah, guys, that concludes our presentations for this evening. So at this time, we'll allow the judges 5 to 10 minutes to deliberate, because everything is written down, and I assume it's just now putting it all together to average it out. And then once that is done, we will present our winners and then do a final remarks, some closing remarks. So yeah, judges, I hope the 5 minutes will be sufficient. You guys can go to the bathroom or something, but we can't go too far, because as soon as they're done, we're going right into it. But are you going to the Joburg branch pedal on Saturday?
They didn't invite me
until yesterday. So they said you're like a person, like...
I'm going, but I'm not going to.
Okay. to register. We have to make it all register. It's like our but Stellenbosch is all the time. Also just count. What time are you getting there?
What time does it start?
I think 9. I'll be your chaperone.
But it's so interesting.
The women's yes, I didn't actually know like that. I mean, you can see it's fun. The boss, you can go, but everyone can.
I can see how you
Oh, yeah? Thank you very much. You guys are giving me a lot of confidence. Always go under pressure like put up with just buckle up. So it's time to be
Can
doing
I
this.
order you doing? Oh, and you're trying to squeeze in the house.
No, you see, that was my fault. He literally said to sleep 2 weeks before. And I lost and found from here. How did things get lost and found so quickly? Like, the person lost and found. So I'm like, how did it get lost and found while we're still here? Because the person probably left from the chair, so I took from the chair and lost and But yeah, man, yeah, but no, he wasn't too mad about it. Council's one of those where you can always run council.
No, well, he wanted to be on
Oh, you got on council, you want to be on So this is first, second, but like in terms of the sponsors.
One, two.
And the sponsors going to say anything?
Victoria, please.
Huh? Say not. No, they had like a stutter.
And there's a thing that I've done initially. The way my language and I want to hear each other. So we got so I'm telling you like and I'm sure I've explained. I'm like, I should have explained. And you didn't know the thing is, exactly the thing is, you never saw the time. And then on the day you see each other.
But I'll come give you my camera. Sure. All right, guys, so yeah, it's the moment that we've all been waiting for, the moment of truth. The moment of truth. So yeah, guys, all the presentations today, I was just speaking to the CEO that all the presentations today were amazing, and you guys chose like very practical problems to solve, and yeah, a lot of them have come with like giving people business ideas, so don't be mad if somebody calls you up and says, guys, we need to collaborate and go to Shark Tank together. So yeah. So without wasting any time so that those who need to leave can leave, because we are over the program, I'm going to start by going to our third place. Our third place. So yeah, guys, can I get a drum roll for third place? Because in third place we have William Pierce from the Stellenbosch University. Thank you, Prof. Roth, and the CEO, please join us up to with Spraylock. Could you guys please come up so that we can present the award, because Spraylock was the sponsor of the third place prize. Could you please join us? Thank you very much. I think Prof. and could you guys please stay? Well done, William. Well done, William. Next, we'll be going on to second place, where in second place we have, drum roll please, Akila Sharif from UCT. So McAfee is the sponsor for the second place prize, but they're not here, so yeah.
And Victor's doing his master's there as well. So.
I am.
Well done.
Thank you very much. Yeah. And then for the first place prize, can we get that final drum roll, please? We have Cyan from the University of Pretoria. Please come up and receive your first place prize.
Guys, this is not great.
And could we please get our sponsor from BVI to please come to present this prize? Thank you very much to BVI for sponsoring the first place prize. I'm going to stand right here next to our CEO.
We need one picture of the HOD.
Yes, please.
He's gone.
No, he's still here?
Oh.
Thank you very much. And then Prof. Krover, could you please join the picture? Well done, Sam. Again, all the presentations were amazing, and I think this is one of the best like research outputs that have come out. So, yeah, it was these were very good presentations, and yeah, well done, guys. Last but not least, could we please have our Saice CEO to please come and give us some closing remarks?
Thank you so much, Victor. Thank you, everyone. As we officially close this year's IP Showdown, I'd like to take a moment to reflect and to thank the people who made today's IP Showdown a success. As Victor said, this is really like every single year, we're just getting better and better with this, and also with the quality of the presentations, and also the interesting, innovative things that are being done on our campuses. So congratulations to our winners. Congratulations as well to those who did not win. It takes a lot of courage to come and stand up in front of people that you've never met and present your final theses and the likes. Your achievement is well deserved. And to every team who participated, from my alma mater, UCT, University of Johannesburg, University of KZN, University of Pretoria, Stellenbosch University, and University of the Witwatersrand, thank you. You brought your energy, you brought your preparation, your professionalism to this competition, and the standard was very high. I'm sure the judges feel like that as well, across the board, and you made it very competitive and very meaningful, so you should really be proud of yourselves. What stand out most is not just the technical ability we've seen, but the quality of thinking, the confidence that you've displayed, the clarity in presenting your ideas, and those qualities matter as well, and that's what will set you, apart within the industry. To our sponsors, BBI, Spraylock, Macaferi, and the University of Pretoria, thank you for your continued partnership and support. Your involvement goes beyond branding. It reflects a real commitment to developing young professionals and strengthening our industry. We value that partnership deeply. Prof. Kraba, the HOD, who has been with us the whole time, thank you very much, and I'm sure it's very pleasing for you to see one of your students, your past students, becoming the winner again. We also had University of Pretoria winning last year, so it means we'll be back, because every time someone wins, we go to their campus, so we'll be back next year again. Prof. Chris Roth, our president, I'm sure you're very pleased seeing that this is your place of employment. And congratulations, I'm sure it means a lot to you as well to see the work that your colleagues are doing with your students. Lecturers from other universities, thank you very much for your attendance, parents who've come to support their children, media and friends as well. We're really grateful for your attendance here and for staying with us. Thank you to our judges, thank you Shireen, thank you Victor, thank you Rufilwe, thank you Lemo, thank you Puti. Some of you have joined us for the second year running now. Thank you for your time, the questions that you've asked, the care that you've put into it, and your questions are very challenging, but fair, and your feedback has really added real value to every team's experience. I want to also thank you, Victor, for emceeing so well. It's been so great to watch your career progress in the last 3 years as the chairperson of FLP, and also the host of our IP Showdown. To our national office and everyone who worked behind the scenes, thank you, Sibo. And the marketing team, and Tabeleng, Sia, Naledi, and Lucky as well, who was at the stand. From planning and coordination to communication execution, events like this really require detail and dedication, and we are really grateful that has been delivered. The IP Showdown is more than just a competition. It is a platform for connection as well between university, between the industry and future professionals. We had some media houses here as well, so they'll also be flighting it within the media within this week. Today has shown us what is possible when we create space for collaboration and healthy competition. Thank you to every participant. Thank you to our photographer, Jeriz, who is a mother of a 2-month-old baby as we speak. To every sponsor, judge, and team member who contributed, we look forward to building on this success and seeing how this platform grows and continues to grow. I wish you well. Please travel safely in the rain, and we hope to see you again next year, same venue. Thank you.
And with that concludes the IP Showdown. Thank you very much. All the participants. Here, right here? Over here or outside?